Hello friends, welcome back to Civil Engineering Master. In this video, we are going to discuss how to analyze and design G+3 building using Etabs software. So this analysis includes not only gravity loading, this includes even lateral loads, which is seismic load. So please do watch this video till the end. Without any further delay, let's move on. First, let me explain you about the architectural drawing. This is the ground floor, typical floor plan and terrace floor plan. It is a residential building. So here we have the ground floor roof framing plan, which is having beams and column, and first floor roof framing plan, second floor roof framing plan. First floor and second floor roof framing plans are typical plans, and this is the third floor roof framing plan. In third floor we only have this area like bedroom and staircase headroom will be having in the terrace floor. So that is why this third floor roof framing plan consisting of only this area. And let me show you the elevation. You can see this is the plinth top. So below this there is a foundation. So that height is 6 feet 6 inches and all the above floors are 10 feet height. You can see plinth top, ground floor roof, first floor roof, second floor roof and third floor roof. And here I have all the dimensions. I have converted into meters. Now let's start modeling the same in Etabs software. Go to edit story system. Here give modify show grid system, display grid as spacing, select this one, and then here you can add one more grid. So we have 10 feet 4 inches, 9 feet, 8 feet, 10 feet 4 inches. These four values we can enter here. First one is 10 feet 4 inches and then 9 feet, 8 feet and again 10 feet 4 inches. And next here also we can add an Etab. We have to enter these values from bottom to top. 9 feet, 14 feet 3 inches, 1 feet 6 inches, 7 feet 2 inches. So here it is 9 feet, 14 feet 3 inches and next one is 1 feet 6 inches and next one is 7 feet 2 inches. See, we got the value. So I told you, right? So Etabs 1 2 3 4 5. This grids looks like this, but in AutoCAD we usually draw the grids like this 1 2 3 4 5. So that's why we need to enter from bottom to top. So now we have the base model. So now we need to enter the story data, stories and grid system. So story data we need to enter. Go to modify and show data. So here we have to enter the story names. First one is plinth. Next let me keep it as GF roof, that is ground floor roof. Next one is first floor roof and the next one is second floor roof, and we can add one more here. Add story, give existing story heights, give OK. Here it is terrace floor or third floor roof we can give. Now we need to enter the height. Plinth height is 6 feet 6 inches. This one is 10 feet and again 10 feet and again 10 feet. This is also 10 feet. We have entered all the floor heights. Next we need to select this master story. So I'm not going to keep anything as a master story. Similar to none. Give OK. You can check in the 3D model. See, whatever the heights we have entered, everything has appeared here. You can check here from move up and down list. See, this is plinth. The height is 1.98 meter. And if you go up, it will show you as ground floor roof. And then again, it is first floor roof and second floor roof and third floor roof. So this is how Etabs will show you all the floor details. Next, let's define the material properties. Go to define material properties. So here add new material, select India and then here select concrete. So here we are going to select concrete grade as M25 and see all the values are here. Give OK. Next again add material. Here instead of concrete go for rebar and select HYSD grade 500. Give OK. And again give new material and select HYSD 415. Give OK. Next let's define section properties. Go to frame sections. Here add new property. Select concrete. All my columns are 225 by 450 size. Here select M25 grade. Concrete rectangular size you have to give here. 450 is my depth and 225 is my width. Modify and show property. So here moment of inertia about 2 axis is 0.7. This is for columns. Give OK and modify show rebar. So here it is column rectangular, cover is 40 mm. So here you have to select the rebar material. For longitudinal bar you need to select HYSD 500 and for ties you have to select HYSD 450. So next here longitudinal bar size and area, this that will provide accordingly. So you can select 16 mm here. For time being I'm selecting this one. And confinement bar, this is for lateral ties, 8 mm is fine. Give OK. And then we can select all this and delete everything whichever we don't want. Give OK. Next let's define the beam properties. Go to define material property, section properties, frame section, and add new material, add new property, concrete. Here let's give beam 225 by 450 M25. Here you have to give the depth 450, width 225. Go to modify show rebar. Moment of inertia for beams is 0.35. Give OK and then modify show rebar. Here select beam and here give 500 for longitudinal bars, 415 for confinement bars. Give the cover as 25 mm. Give OK. And one more thing, here we have 3 circular columns, 1 2 3 circular columns, that also we need to add. So go to add new property, select circular column 225. I took this dia as 225 M25 grade, and then here give 225. Modify show rebars, and again moment of inertia for column is 0.7. Give OK, and then here select the grade of steel. Give OK. Next go to define section properties, slab sections, add new property. I'm going to add S125. My slab thickness is 5 inches. M25. Give shell thin and then 125. Here slab type. Give OK. So now all the properties have been defined. Now let's start drawing the column. Before drawing the column, what you have to do here, instead of one story, select all stories. This will save our time because whatever the column you are going to place in this story, that will replicate in your all stories. So I'm going to select this quick draw column option. So here my column size is 225 by 450. So I'm going to place in this place all the 3 columns, and then again here there are 2 columns, and I'm going to place one column here, one column here, and again in the last row, last 2 columns, here one column. And see these 3 columns are in the vertical direction. Even I'm going to delete this because this is also in vertical direction. Again select quick draw option. Here select the angle, give 90 degree. Now you place the column here. Here 2 columns, here 1 column. See, all our columns are placed as per the framing plan. Next we need to add 3 circular columns over here. Go to this quick draw option and select here circular column, and here provide 0, there will not be any angle, and place the column over here. So we are done with the columns. If you see in 3D view, you will be come to know you have added columns for all stories. Your columns are added for all the stories. So that's why I told you have to select here all stories. Now let's start drawing the beam. So before drawing the beam, you have to select the one story here, because beam layout is different for all the stories. Only first floor roof and second floor roof framing are same. So we need to select one story here. So go to quick draw option, quick draw beams. Sorry, this is column, this is the beam option. Quick draw beam. Here I'm having the plinth beam layout. Here I need to select beam, and then I can draw beam like this. So this is the beam, and again this full row we have beam, and here again select, we can draw the beam. Here also you can draw. This one you can delete. So it is done. We have drawn all the plinth beam layout. Here one more beam we need to add. Next go to next story. So we have to go to ground floor roof. See, here we need to add the beams. Again select quick draw beams. So we have one beam here. In this area we have beam. This also we have beam. Here we have beam. Here we have beam. Here. That's all. We are done with ground floor beam. So here what we have to do, this we need to check whether these 2 beams are divided at the intersection or not. And again here it is a single beam only. We need to merge beams, join frame. And next what we have to do is, here you can see one cantilever beam is there. So let's check that length, and then let's add that beam. See, it is 3 feet 4 inches. Let's keep it as 1 meter. Simply I am going to copy and paste this one. So in the x direction it is 1 meter. Okay. Now just you can select this beam and then add one beam. We have to draw beam between these 2 columns. Now you can select this column and delete. This is done. Next, let's go to first floor roof. First floor roof has come. Go to quick draw beams, add beam here, and here we have to add little bit offset we need to provide. So let me show you how to do that. First we can draw beam here and then draw here. Here one beam is there and here one beam is there. Here also we need to give offset. See 1 feet 2 inches from outside. If you consider from inside, center distance, it becomes around 2 feet 3 inches will come. So let's take it as point. Control C, Control V, negative direction. Let's take it as 0.615. So now we can delete this. See, it looks the same. And again, from this grid, we need to move this beam. So it is 5 feet 1 inches. And again, if we take center distance, it comes around 5 feet 6 inches. So let's take Control C, Control V. In the Y direction, you have to give 1.67. In this one, we can give join frames. And again, here you have to select this one and this one as well. Go to divide frames, break at intersection with selected frames and joins, give apply work. Because then only, see, this is the main beam and this is the secondary beam. So that if it is break at intersection, then only this beam will behave as a main beam and this will behave as a secondary beam. So that is why we are just breaking at intersection. See again, this is single beam. So we need to again break this one. Select these two. Go to divide frames, give apply, OK. See, this is also got break. This is a single beam, so we need to merge this one. Again, we need to break this one. Divide frame, break at intersection. See, again here we need to break at intersection. This looks exactly same as this framing plan. Now what we can do, we can just copy this one and replicate to the second floor because it is similar. Second floor and first floor roof framing are similar, so we can copy this one. Even we can copy to terrace floor as well, and then we can modify accordingly as per this third floor roof framing plan. I have selected all the beams. Next, let's do replication. Go to replicate. Here select second floor roof and third floor roof, apply, OK. See, all the beams have been replicated to second floor and third floor. Now we can go to respective floors and then do the modification. There is no modification in second floor roof since both are similar. Let's go to third floor roof. So here we'll be having only this portion, this area. So let's select rest all the beams and then delete it. So now go to 3D view. Even we don't want these columns in the third floor roof. So let's select those columns and then delete only in the third floor roof. Next we need to add slabs. So quick draw floor option you can select and then here select the slab thickness 125. So this area is the staircase area. It is a cutout, so there will not be any slabs over here. We can add here. That's all. Now we need to do merge. So here you can give merge cells. OK. So this will become one slab now. And again these two you can merge. Give OK. This is a single slab. And these two you can merge. First floor roof. So here let's add the slabs. So these two you can select and merge, give OK. Now we need to cut this one. So for that select the slab as well as beam and then go to here, apply, OK. So see, now the slab is splitted. These two you can select and merge. So it's very important while modeling you have to do properly. Then only all the loads will get transferred properly and you will get the proper results. See here also the same problem. So you have to select this beam and then this also you can select this beam, give divide shells. See now it is divided. This is a single slab and this we need to merge again. This one and this one, this one and this one you need to merge. Now you can see all the slabs are single slabs so that the beam loads will get transferred properly to the slab. If the slabs are not proper, the load will not get transferred to the beams properly. Whatever the slab load we are entering, that is getting transferred to the beams, right? So if the slabs are proper, then only it will get transferred to, the load will get transferred to beams properly. We are done with the first floor roof. Next we need to replicate the same to the second floor roof since it is similar. So let's copy these slabs. Selected, all the slabs are selected. Go to 3D view and then replicate. Here select second floor roof, apply, Okay. See, the same has been replicated to the second floor roof. Now come to plan and then go to second floor roof. See, the slabs are there, and next go to terrace floor. So here we can add only here this headroom will come, and then let's add one slab here. Select these two slabs and then give merge. Here even these two beams we need to join. You can see in the 3D view, we are done with the model. If you want to see in 3D view, go to extrude frames and cells, apply OK. Model is ready. Next, let's go on apply the loads. Next, we need to define the loads. So before that, I'll show you the load. What are all the load we are considering? Under dead load, self weight of the slab. So this Etabs will calculate automatically. Main wall load, wall thickness is 225 mm and unit weight is 20. Floor height is 3 minus beam depth. So that will become the wall height. So I'm getting wall load as 11.48. This is the partition wall load. Floor finish load 1 kN per meter square I'm taking, and partition load 1 kN per meter square. Parapet wall load, wall thickness is 9 inches and then parapet height is 1 meter. So I'm getting 4.5 kN per meter. Staircase load, I'm having RA is 14.4 kN and RB is 16.02 kN. I'll show you here. So we are having the staircase like this. So in this area I'm having 14.4 kN and this area I'm having 16.02 kN. We need to add the mid landing beam in all the floors and then we need to apply the loads. Mid landing beam load is 14.4 and roof beam load is 16.02 kN. And we have one cantilever slab. Let me show you here. So this cantilever slab, we have 4 feet 6 inch cantilever slab. So this load I have converted into UDL and I'm going to apply on this beam. So that's what I have shown here. This load is 7.125 kN per meter square. So that one I have converted into load into the distance of the cantilever. So I'm getting 9.77 kN per meter as a UDL and live load is 2 kN per meter square. Let's see the earthquake parameters. Location is Kanpur. Soil type medium. SA by Z value is 2.5. Zone factor is 3. Importance factor is 1. Response reduction factor is 5. This I'll explain you while applying the load. First let's define the loads. Go to define load patterns. So here dead load which is 1. Self weight multiplier is 1. And next let's add main wall load. Under super dead load self weight multiplier is 0. Add new load and then partition wall load, that is also super dead load. Add new load. Floor finish plus partition. Add new load and staircase load. I'm writing stair mid landing beam MLB I'm writing. That one I'll add and then roof level beam. I'm adding RLB, roof level beam. So those two loads will come under super dead load only and cantilever UDL. Add new load. So these all comes under the dead load case only. Next live load it is already added, that is 2 kN per meter square. You have to be very careful with this all. Why we are having self weight multiplier as 0 here is because we are going to enter these values manually and only self weight multiplier for this all the dead load of the members, that is 1 because Etab will calculate automatically. Next we need to define the seismic loads, that is EQX. Select the load type as seismic and here you have to select the code IS 1893 2016. Add new load and again EQ Y direction seismic, the same load. Add new load. We have defined all the load cases. Before assigning the load, let's assign the support condition. Go to base, select all the joints and then go to assign, click joint. Here under restraint you have to select the fixed support, apply OK. Now if you go to 3D view, you can see our support has been assigned. See, it is fixed support. Next let's move on to plinth layout and then assign the loads. Go to assign, under frame load select distributor. Here you have to select the main wall load and then direction of load application is gravity. Here the wall load is 11.48 kN per meter. We have to select where the wall load is coming. The beams we need to select. See, all the outer beams have been selected and then give apply OK. Now let's assign the wall load on the plinth beams. Go to assign frame loads distributed. So here main wall load we need to choose and then Direction of load application is gravity and wall load is 11.48 kilonewton per meter. So we need to select all the outer beams to apply the main wall load. Here as well, apply. Okay. See, all the main wall load has been applied. Next, let's look into this one. So here we'll be having the partition wall load in this area and here. So let's apply that one on the, go to assign again and then frame loads distributed. So here select partition wall load 5.71. Apply, that is also done. So that's all the load we need to apply on the plinth beam layout. Next, go to ground floor roof. So on ground floor roof again we need to apply the main wall load similar to plinth beam. Go to frame loads distributed, select main wall, give apply. Okay. Next we need to apply the partition load. So partition wall is here and then here. So let's apply this one. Go to assign frame loads distributed, select partition load 5.71, apply. That is also done. Next we need to apply the staircase load. So for that we need to go down in the plinth level itself, we need to assign. So the staircase is starting from here. Go to assign frame load distributed, go to staircase roof level beam which is 16.02. This is the beam. Apply. Okay. And let's come to 3D view. So here let's select this one, give Ctrl C, Ctrl V. In Z direction it is 1.5 meter, negative 1.5 meter we have to give, so that if you see this is plinth level and in between this is the roof level and in between we have one mid landing beam, and similarly we can add here as well. It is added now. So select all the mid landing beams and then go to assign frame load distributed. Here select star mid landing level beam 14.4 kilonewton. Apply. Okay. So it is assigned. Next, let's come to the plan view. Go to ground floor roof. We have to apply the staircase load on roof level beam. Select this beam. Go to assign frame loads distributed. So here select staircase roof level beam and the load is 16.02. Give apply. Okay. So it is done now. Next we have to apply this cantilever slab load. As I have told you before, here we are having 4 feet 6 inches cantilever slab that has to be applied as a UDL on this beam. So we have to select this beam and then go to assign frame loads distributed and here select cantilever UDL, give 9.77. Apply. Okay. And then next we have to apply the loads on slab. Select all the slab, go to assign shell loads, go to uniform and then select floor finish. So that is including floor finish and partition load is 2 kilonewton per meter square. Give apply. Okay. And again select all the slabs, go to assign shell loads uniform and select live load. Live load is also 2. Give okay. So that is done. Next let's go to the upper floor which is first floor roof. So here first let's apply the wall load, main wall load. Select all the outer beams. Go to assign frame load distributed. Select main wall load. Main wall load is 11.48 kilonewton per meter. Apply. Okay. Next partition wall load we need to apply. So select this beam. Next we need to apply the partition wall load. So select all the beams where the partition wall load is coming. Go to assign frame loads distributed. Select partition 5.71. Apply. Oh, that is done. Main wall load is done. Partition wall load is done. Next we can apply the staircase load on this beam. So already mid landing beam staircase load has been applied for all the beams distributed and staircase roof level beam. The load is 16.02. Apply. Okay. Next we have to apply the slab load. Select all the slabs. Go to assign shell load uniform. So you have to apply the live load as 2. Now let's assign the floor finish load and partition load as 2. Apply. Okay. So it is done for first floor roof. Next let's go to second floor roof. So here we have to check with the architectural drawing. In the second floor roof only this area is coming above. So only we need to apply the main wall load here in this area. So one partition load will come here and after that we need to apply the parapet wall load on the outer beams. So let's select only this area where the main wall is coming. Go to assign frame load distributed main wall which is 11.48. Give apply. Okay. Next, this is the area where we get the partition wall load. Select partition wall 5.71, apply OK. This is done now. Next, we have to apply the stair load. Go to assign frame load, again distributed, select staircase roof level B 16.02, apply OK. So now we get all the periphery of the wall. We have to apply the partition wall load, parapet wall load. So in this area we'll be having the parapet wall as you have seen in this architectural drawing. So this portion will be hitting the parapet wall. Go to assign frame load, distributed. Here select parapet wall load, that is 4.5 kilonewton per meter. Give apply. Parapet wall load has been assigned now. Now we have to apply the slab load. Select all the slabs. Go to assign shell load, uniform, floor finish 2. Go to select, get previous selection, and apply OK. Next, go to terrace floor. So here there will not be any wall load coming on the beams, and what we have to do is we have to apply only slab load. Select all the slabs. Go to assign frame load. Go to assign shell load, uniform, and here live load we can apply 2, and floor finish we can reduce it further. Go to assign shell load, uniform, floor finish, let's apply 1 only. So that's all about the loading cases. So we have done all the load. Next, let's assign the self weight. So before that, let's select all stories because we are going to apply the self weight for all stories. You select all and then go to assign, select joint loads, force, keep it as dead load pattern as dead load, and here everything you have to give 1 because for dead load self weight multiplier is 1 and give apply OK. So self weight is assigned now. Next we have to define the diaphragms. So before that let's assign the earthquake load cases. Go to load pattern. So here we have already defined EQX and EQY. So let's select that one. Modify lateral load. Here you have to consider only X direction. So we are not considering any eccentricities. And story range, bottom story you need to select plinth because plinth level is starting from the ground level. So earthquake takes place at ground level, not below ground level. So always you should not consider the basement floors which is below ground level. You have to start from the ground level, and top story is third floor roof, and response reduction factor is 5. Let me show you this from code. In IS 1893-2016, Table 9 response reduction factor for R4 building systems. So if you see here, moment frame system, RC building with ordinary moment resisting frame, OMRF, that is 3. The value of R is 3. We have to check with note 1. RC building with special moment resisting frame, SMRF, that is 5. So let's check the note 1. RC and steel structure in seismic zone 3, 4 and 5 shall be designed to be ductile. Hence this system is not allowed in these seismic zones. Because this condition A, that is RC building with ordinary moment resisting frame, is not applicable for the zone 3, 4 and 5. Let me show you once the earthquake parameters. So our location is Kanpur, soil type is medium, zone 3, importance factor 1, response reduction factor 5. As we have read the condition, we have to go with RC building with special moment resisting frame. So for this condition, the response reduction factor is 5. So that is why I have taken 5 in Etabs. And here zone factor we need to consider. So as per the code, in table 3 seismic zone factor is given. So our zone is 3. So for that value is 0.16. So 0.16 is the value, zone factor value for zone 3. So here we have to enter 0.16 and soil type is medium. This is normal, medium and then hot. So medium we need to consider. Importance factor is 1. That also I'll show you in the code. In table 8, importance factor is given. So our building is not a special building like a school building or commercial building, and second one is residential or commercial buildings other than those listed in serial number 1 with occupancy more than 200%. So ours is normal building. So all other buildings importance factor is 1. So we need to consider the importance factor here as 1, and here time period we need to calculate. This we can give program calculated, or else even we can give user defined. So this is the formula for calculating the base shear. VB is equal to AH into W. AH is the seismic coefficient, W is the weight, and VB is the base shear. lateral force. We can say it is a lateral force or a base shear. And W we need to calculate as per 7.4. 7.4 is the class number 7.4. Seismic weight we need to calculate. Seismic weight of each floor is its full dead load plus appropriate amount of imposed load as specified in 7.3. So here in 7.3 the table is given 7.3 class. Table 10 is given percentage imposed load to be considered in calculation of seismic weight. So up to and including 3 kilonewton per meter squared of imposed load, we need to consider 25% of live load, and above 3 means we need to consider 50% of the live load. So this is the live load factor we need to consider while calculating the seismic weight. So here we have formula in equivalent static method. As I told you before, this is the formula, base shear calculation formula. AH multiplied by W. AH we need to calculate seismic coefficient and W. So to calculate AH we need to calculate the T, time period. See here, without any masonry infilling, we have to go for this formula. For all other building, we have to go with this formula. T is equal to 0.09 h divided by root d. So here h is the height of the building and d is the base dimension. So using this formula, we can calculate the time period and we can enter the value here, time period in seconds. Or else we can give program calculator that will automatically calculate the time period according to that formula. Give OK. Next, similarly, let's select EQY and go to modify lateral load. So now select only Y direction, and similarly here select plinth and third floor roof. Response reduction factor is 5, zone factor is 0.16, soil type is 2, importance factor is 1, and time period let's keep it as program calculated. Give OK. Now we need to add the load combinations. Go to define load combination. So here there are two options. One, you can add manually or you can go to add default load combination, and here you have to select concrete frame design. This one you can select convert to user combinations, so that the load combinations will appear here according to the lateral load whatever you have applied. So we have applied only earthquake load in positive x and positive y direction, and for that how many combinations will come, that and all will be here. First one, let's modify into 1 times dead load plus live load, which is unfactored load. This we can modify the scale factor 1. Live load is also 1. Give OK. Next load combination we can modify as 2, that is 1.5 times dead load plus live load. So here everything is 1.5, dead load, live load, and all other loads are 1.5. Give OK. And again this, if we go, this is 1.2 times. So let's select this one and see. This is 1.5 times dead load plus EQX. This is positive EQX. If it is negative direction, here the 1.5 value should be in negative. So dead load plus, this is my load case 3, which is 1.5 times dead load plus EQX. Give OK. And next one, modify. See, it is negative EQX. So here you can add my load case 4, which is 1.5 times dead load minus EQX. Give OK. And next you can check, it is EQY. So this is my load case 5, 1.5 times dead load plus EQY. Give OK. And next this one, 6th one, 1.5 times dead load minus EQY. See, the value of EQY is negative 1.5. So it is done now. Next let's select this one and see. This is the load combination factor of having positive x direction 1.2. So here live load is also 1.2. So I'm going to take this as 7th load case, 1.2 times dead load plus live load plus EQX. Next I'll take this one as 8. So this is negative EQX, 1.2 times dead load plus live load minus EQX. Okay. Next, this is my load case 9, 1.2 times dead load plus live load plus EQY. See, this is positive EQY. Next, 10th, 1.2 times dead load plus live load minus EQY. Give OK. Next, this one is 0.9 and 1.5. EQX is 1.5, dead load is 0.9. So this is my load case 11. 0.9 dead load plus 1.5 EQX. Okay. Next one is 12.9 dead load minus 1.5 times EQX. See here the EQX factor is negative 1.5. Okay. Next, my load combination 13, which is 0.9 dead load plus EQY. EQY factor is 1.5. Okay. Next, 14.9 dead load minus 1.5 times EQY. So all the load combinations have been added. Now we can give OK. Next let's define the diaphragms. Go to diaphragms, add new diaphragm D2, add new diaphragm D3, add new diaphragm D4. So first one, let's modify it as ground floor roof. So this has to be applied there. Second, let's modify into first floor roof. Next one, second floor roof, and next one, third floor roof. Let's assign the diaphragm now. So for that, let's go to set view options, and here let's unselect beam column, apply OK. So that only floors will be available. So the diagram has to be assigned only to floors. I'm going to select all the ground floor slabs and go to assign. Under shell you have to choose diaphragm. So select this one, ground floor roof, apply OK. See, it has been assigned. And next, go to first floor roof, select all the slabs and then go to shell, diaphragm, first floor roof, apply OK. And next, go to second floor roof, select everything and go to shell, again diaphragms, second floor roof, apply OK. Next, third floor roof, go to assign shell, diaphragm, third floor roof, apply OK. Now all the diaphragm has been assigned. You can just check this one, columns and beams, apply OK. Next we need to assign the mass source. So we need to define first, go to define mass source. So here you have to modify show mass source. Here specify load patterns you have to select, uncheck this one, only keep this one. And here what you have to do, dead load, add, main wall load, add, partition wall load 1, and floor finish load add, stair load add. So all the dead weight we need to take, only live load we need to consider according to that percentage given in that table. Live load up to 3 we need to consider 25%, and live load above 3 we need to consider 50% of the live load. Parapet wall, everything has come, the dead load. So only thing is live load we need to consider 0.25 because our live load is less than 3 only. So we need to consider 0.25. Give OK. We have applied all the loads, dead load, live load and earthquake load. Next let's do the analysis. Before doing the analysis we have to check the model. So let's check the model. Select all, give OK. See, there are 5 warning messages. So let's see what it is. Beam 35 and 20, 36 and 20, 37, 19, 37, 40, 38, 19 are overlapping each other. So let's go to ground floor roof. This we need to join. Let's check model once again. Let's copy this one. In these places there are 2 beams overlapping each other. So let's select this one and delete. Again select and delete. Next let's again check the model. All other warning messages has gone. Only B37 and B40 are overlapping each other. So this one we need to fix it. First we need to select this joint and then go to divide. So this become a separate beam and these 2 we need to join. So this is a single beam now. Let's check again. All the warning messages have gone. Now it is good to go with the analysis. Let's run the analysis. So here we can see the deformed shape of the building. Analysis is done. See, you can see here. Now let's do the design and then check the result whether all the members are okay or not. For designing, go to design, concrete frame design, view revise preferences. So here IS 4562,000 and then gamma steel, gamma concrete we need to check. It is 1.15 and 1.5. Give OK and then again go to concrete frame design and here start design check. So it is done. I hope those two circular columns are overstressed. Let's check that one. Go to design, concrete frame design, display design info, identify all failure, apply. Okay. See, these three circular columns are overstressed. You can see the red mark. It is not passing with the PMM. So we need to change this one. And again, let's check. Go to design, verify all members paused. 6 concrete frames have failed the design check. So what we can do is we can just unlock the model and then go to define section properties, frame section, and let's change this column size. Instead of 225, let's add 300, and here also let's give the diameter as 300 and then give OK. So now let's analyze and check whether it is passing or not. Go to design, concrete frame design, start design check. Again, go to concrete frame design, verify all members passed. All concrete frames passed the design check. See, now all the concrete frames are okay, so we no need to change any properties again. So here the reinforcement area is shown here. If you want to see the percentage, even you can see. Go to design, concrete frame design, here design, display design info. So reinforcement percentage, you can select rebar percentage, apply. So that means rebar percentage is shown here. You can see the percentage like 2.2, 2.3.1. Even in beams also rebar percentage is shown here. If you want to know about a particular member detail, just select that member, right click, and then this window will appear. See here, this is the governing load for this member, and click detail. You will be getting the detailed report for that column. See, at plinth level, this is the governing load factor, and you will be getting the load. Everything you will get here. See, whatever the value, dia is 300 mm, we have changed, right? So that is the dia. And here you will be getting axial force and moment. Axial force is this much, and moment we are having here. See here, beam column capacity ratio is 0.9 and 0.48. So this is how the report will generate for each column. Let me show you one detailed report for beam as well. Select that particular beam and then here click detail. See, this is that particular beam. The beam size is 225 by 450. See, shear force is given here. Rebar AST is given here, 510 mm square. Flexural moment is this much, and required rebar is 230 mm square. Top 57 mm square, bottom 230 mm square. All the details are given here. So this is how you have to check all the beam and column reinforcement details. So friends, I hope you all like this video. Please do comment in the comment box if you have any queries. Your comments are always welcome. And don't forget to subscribe the channel for more videos. Thank you for watching.